Hello everyone, welcome to Jiggy Math. Our lesson video for today will be about solving differential equations, particularly homogeneous differential equation. So they are equations that can be written in the form of dy dx equals f of y over x, and it is solved using the substitution of v equals y over x, where v is a function in x. So it requires a little manipulation so that you can have a y over x. Let's take a look at this example. Solve x dy over dx equals x plus y. So notice that we cannot solve this by separating the variables, but what we can do is we can write this in the form in such a way that we are going to have a y over x. So in order for us to do it, we can divide the whole equation by x. So the result is going to be dy dx is equal to x plus y all over x. So simplifying this will be equal to 1 plus y over x. So we have now this y over x, so therefore this is a homogeneous differential equation. So in order for us to solve this, we are going to use the substitution wherein v is equal to y over x, or equivalently y is equal to vx. And if we are going to differentiate this in terms of x, then we have dy dx is equal to v plus x times dv over dx by implicit differentiation. So by using the dy dx, we can now rewrite this in this manner. V plus x dv over dx is equal to 1 plus v, because our v is equal to y over x. So notice that we can cancel out the v here. So what is left is just x dv over dx is equal to 1. And then we can divide the whole equation by x. Therefore, this is going to be dv dx is equal to 1 over x. So now we can integrate both sides of the equation. So the result is going to be v is equal to the integral of 1 over x is ln x plus c. So don't forget to include plus c here. And then of course this is not yet the solution. Our solution must be y is equal to a certain expression, right? So we have to go back to our substitution here. So v is equal to y over x. So this is now y over x is equal to ln x plus c. So multiplying this side by x, so the result is y equals x multiplied to ln x plus c. So this is our general solution to this differential equation. Okay, now let's have our second example. Second example is solve x dy dx minus y is equal to x squared sine x. So once again, keep that in mind. We must have a y over x. Can we have a y over x for this to be a homogeneous differential equation? Yes, we can, by dividing again the whole equation by x. So the result is dy dx is equal to x squared sine x plus y all over x. So simplifying this, we have x sine x plus y over x. So we have a y over x here, so this is again a homogeneous differential equation. So we have to use again the substitution v is equal to y over x, and then differentiate the y is equal to vx using product rule, implicit differentiation. Dy dx now is equal to v plus x dv over dx. Okay, so let's rewrite this using our dy dx here. So it is now v plus x dv over dx equals x sine x plus v. Okay, so again we can remove the v. So what is remaining is x multiplied to dv dx is equal to x sine x. So we can divide both sides by x. So what is left is dv dx is equal to sine x. Integrate both sides of the equation. We are going to have v is equal to the integral of sine x is negative cosine x, and then plus c, and then go back to our substitution here. So v is equal to y over x, is equal to negative cosine x plus c. Then we just have to multiply the x to this to the right side. So the general solution is y is equal to x multiplied to negative cosine x plus c. Okay. All right, so this is how we solve homogeneous differential equations. So in the next video, I'm going to demonstrate on how to look for a particular solution where initial value is given. So at this point, thank you so much for listening. See you next time.